Now take this problem. In this, again a network is given, and this network is resistive, and this is 5 volt source, and this is 4 ampere current, and this is 2 ampere. Okay, now when same network is implemented here, and this 10 volt is applied here, and this 30 volt is applied here, okay, and the polarity is like this, and here polarity is like this. Okay, in this case we have to find this current Ix. So again we will use the concepts of multiple network theorem to solve this question. Okay, here we have to find Ix. So to solve this question, first we apply the principle of homogeneity. Okay, if we apply this voltage source 5 volt by factor k, that is equals to 2, then response in each branch will also get multiplied by factor 2. So if we multiply this 5 volt by 2, then we get 10 volt. Okay, then current in this branch will become 4 into 2, that is equals to 8 ampere, and current in this branch will becomes 2 into 2, that is equals to 4 ampere. Okay, now we will apply the concept of reciprocity. So in reciprocity we simply interchange. Okay, here it is homogeneity. Okay, here we will apply concept of reciprocity. So when we apply reciprocity, here this will become 4 ampere, this current will transfer here, and this will become 8 ampere, and this voltage source will come here, that is equals to 10 volt. Okay, now we get this by applying the principle of reciprocity. Now we apply the principle of homogeneity again. So we have to get this 30 volt on this side. For this we have to multiply this factor, this 10 volt by factor k, that is equals to 3. But here you can see that polarity of this 30 volt is opposite to that of this 10 volt. That's why we have to multiply it by -3. Okay, so multiply this by -3 using principle of homogeneity. We get okay, we get -30 volt here, and current in this branch will become -24. Okay, and what is current in this branch will become, that is equals to, in this direction, -3 -12 ampere. Okay, here -12 means the direction of current is opposite, but we are retaining the direction of current, that's why this negative sign is placed here. So we can also write it as -12 ampere, we can write it as 12 ampere, and this 24 ampere we can also write it as this 24 ampere. Okay, here we have removed the negative sign, so there is no difference between these two no representations. Now we will apply the concept of superposition. See, here we get this 10 volt, okay, and here in this circuit we get this -30 volt. Okay, so this is +30, because we have already changed the polarity, that's why it is +30. Now superimpose this first and this second. What we get on superimposing this, we get, here it is not visible, so here I draw this. Suppose here it is this is 30 volt. Okay, and on superimposing this we get 10 volt here. So we can define this superposition of 1 and 2 as, suppose if this 30 volt is applied with this polarity, then current in this branch is 12 ampere in this direction, and when this 10 volt is applied to this circuit and making this 30 volt short circuited, then current in this branch was 8 ampere. So when we apply this 10 volt and this 30 volt simultaneously, then current IES in this branch will be equals to, this IES will be equals to this 12 ampere that is in same direction, that is 12 plus this 8 ampere. Okay, this 8 ampere, so we get 20 ampere answer. So here in this question we use multiple concepts of network theory. We use the principle of homogeneity, we use the principle of reciprocity, and ultimately we use the concept of superposition. Okay, I hope you understand this concept. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.